Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to discuss how we can use Raspberry Pi 4 for detecting wrong way traffic. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we are going to discuss how we can use a Raspberry Pi 4 wrong way traffic detection. So for that I have created a repository RPi4 wrong side traffic detection. I will mention the link. You need to simply copy paste the link inside the browser, then go to the code, and then we are going to copy the link. So just copy the link from here, copied it. So we copy our link and we want to simply clone our repository. So for that, open the terminal and let me make zoom in here. I hope you all see clear. Now simply we copy our link. Now we want to run the command git space clone and paste the link of repository and just hit enter. It will clone our repository. So let's just open file manager, and here as you can see RPi4 wrong side traffic detection. This is what our repository. Inside that we have our video file. So let's just play our video file with the help of VLC media player. And friends, as you can see, this is what our video file, this is what our scenario, this is the CCTV recording, and here it is. As you can see, the traffic flow is like this way. It's going this side, and there is a one car. As you can see, this car is basically going wrong side. All the car is basically going this side and this car is basically going this side. So our goal is to detect a vehicle which basically going wrong side. So for that, let's just first close our video file. So I have create here a Python code. We have our tracker.py for tracking the vehicle, and we have our main Python code which is test1.py. So right click and open with Tony Python IDE. It will open our code with the help of Tony Python IDE. So simply first we want to install the packages. So go to the tools, manage packages, and we are going to search for opencv-python, hit enter. opencv-python, first package, click on it, click on install. It will install opencv-python. Then we need opencv contrib python, opencv-contrib python, click on search on PyPy. opencv-contrib python, first package, click on install. It will install opencv-contrib python package also on our Raspberry OS Bullseye 64-bit version. This is the Raspberry OS Bullseye 64-bit version, the latest version. Simple. So this is what our code. Of course we want to import our CV2, then we are going to use our tracker. So we want to simply call our tracker in our main code. So this is what our tracker.py. So we want to use our tracker. So for that we want to call our tracker inside our test1.py, which is our main code. Then import CV zone, numpy as np, import OS, from date time import date time. We are going to basically, when we detect a wrong side vehicle in our selected area, we are going to save the image with current date and current time in the folder. Simple. For that we call here import OS, and from date time import date time function. So this is what our video file. Then we are going to use here for object detection, we are going to use a simple create background subtractor mock2. So FGBG is basically a simple variable. You can mention any variable. So this one is basically the variable, and this is what our object detection method. For this we are going to simply use a background subtractor mock2 method. Then this is what our area. This is what our area. In this area, if our car there, then we can see car is basically going wrong side. Simple. So then we want to call our tracker. So tracker is just a variable, and we want to call our tracker class. So inside tracker.py we have tracker class. As you can see, the T is basically capital. So we want to call our tracker class inside our main code. So tracker is just a variable and we want to mention tracker is equal to our tracker class. Then this is basically a dictionary where we are going to save our all vehicles, means the vehicles which basically going wrong side. So inside this A1 dictionary we are going to save their current ID and their current position. So counter, because we want to count the vehicle also, so for that I have created here counter variable. Then this is the function for saving our image inside the folder. When we detect the vehicle which basically going wrong side in our area, then we want to save their image. So this is the simple function for saving the image. Current date time, because we want to mention here date time, because we want to save the image as an extension which basically the current date and time. So we want to mention like this way: current date time is just a variable and date time dot now strf time, and this is the method. Then folder name is equal to, we are going to create here wrong way folder. The folder name is wrong way, and inside that we are going to save our all images. Then if there is no folder, of course we want to create here a folder. Then we are going to simply use os.path.join method, and then we are going to mention here our folder name, and inside that we are going to save our image like this format. The frame and the current date time and the extension of our image is basically .jpg. Simple, a basic code. This is how we save our images. Then simply we have our cv2.imwrite function for saving our images. So cv2.imwrite function, the file name and the frame. Frame is basically when we detect the object inside our area. Of course in that time only we want to save that particular frame. So cv2.imwrite image file name, and we want to mention our frame. Then this is what our while loop basic code, and fgmask is just a variable. fgmask is just a variable. Now we want to call our background subtractor. So for that fgbg, so fgbg is basically our subtractor. As you can see, we mentioned fgbg is just a variable which represent our create background subtractor mock2 method for subtracting basically the background. So fgbg, this is what our method. So we want to call, if we want to call our subtractor, so we want to call simply our variable fgbg. So fgbg dot apply, we want to apply our background subtractor on our frame. So simply we want to pass our frame. With 1020 is basically width and 500 is basically the height. Then we are going to use here cv2.threshold method, and inside that we want to pass our mask image and then 250 and 255. So this is the coordinates, and then we are going to use cv2.thresh binary method. Then of course simple contours detection method. So contours is basically cv2.find contours, then we want to pass our thresh image. Then this is the basic method for detecting the contours, cv2.return external and cv2.chain approx simple code, friends. Okay. Then for contour in contours, now we want to mention the area, the contour area. So if the contour area in contour, if it is greater than 1000, then only we want to detect our object. So after that, here it is, as you can see, this is what our condition. After that we want to simply mention x, y, w, h is equal to bounding rect method, and then we want to pass our counter. This is how we will get our object. This is the method for object detection. X, y, w is basically the rectangle when we detect the object, and of course we are going to draw a rectangle. Simple code. Then now we detect our object. Now simply we want to track our object. So for tracking object we have our tracker.py. So simply list.append. If we want to use our tracker, we want to simply send our object rectangle coordinates in our tracker. So list dot append, and we want to mention our x, y, w, h. As you can see, I have mentioned x, y, w, h. This is what our object coordinates. Object coordinates in the sense, if we detect the object, of course we are going to draw the rectangle. So the rectangle is basically our detected object. So if we want to track our object, so we want to send our rectangle coordinates for our tracker. So x, y, w, h, and here I have created the list dot append, pass x, y, w, h, and then create here list. Now we have our list. Simply we want to create a new variable. We done with object detection. We are sending our coordinates to tracker. Now we want to call our tracker method in our main code. So bbox idx is just a variable, and tracker is basically our variable. Tracker is basically our variable which represent our tracker class. So we want to call this tracker. So here bbox idx is equal to tracker dot update, and simply pass the list. As you can see, I have passed the list. Now it will send our rectangle coordinates to our tracker. Then for bbox in bbox idx, now we have again new coordinates with the help of tracker, which is basically the rectangle coordinates. Also our tracker will assign the id for each object. So for bbox in this bbox idx, we want to create here new 4 variables for rectangle, because now we have the rectangle coordinates with the help of our tracker. So x1, y1, w1, h1, and the id is equal to our bbox. Simple. Then we want to mention a rectangle center point. This is what our object center point. So cx is basically int x1 plus w1 divided by 2. cy is equal to int y1 plus h1 divided by 2. This is how we will get our center point. Then now we have our center point. Now what I am going to do, simply I will start the code, but let me first freeze our frame. Okay, so I have freeze the frame. So now it will draw a polylines. As you can see, this is what our scenario. So as you can see, I have drawn here 2 polylines. So this one is first, the green color is the first polyline. As you can see, c2.polylines frame np.array area 1 np.int32, and this is the coordinates. This is the coordinates for area 1. So how do we get the coordinates? Simply, if you move your cursor on the frame, here it is. As you can see, we have x, y coordinates, x and y coordinates. So the x, y coordinates is continuously changing because we are moving our mouse. So if you want to get the coordinates for particular points, simply we want to move our mouse on that particular point, and we want to simply copy the x and y coordinates. So right now, let's say I want to draw here a polyline. So if I move my cursor over here, so here x is basically 568 and y is basically 255. So let's just say I want to draw here this is the point I want to start my polyline. So just move here 832246. So next point 659263. So next point here 681315. So this is how you will get the coordinates here, x and y, the live coordinates, the mouse coordinates. So this is how I have mentioned this area 1 coordinates, and simply with the help of c2.polylines we can draw a polyline using our area coordinates. So this is how I have drawn these 2 polylines. That's it. Now we have our area. Now we detect our object, we track our object. Now our goal is to detect the object if the object is basically going wrong side. So what is the flow? The vehicle flow is basically this side. As you can see, this side. So if the vehicle is going this side, from this side, so of course we can say the vehicle is going wrong side. So what is basically action? So the car center point, first it will insert this area. So this is what our area 2 in red color. As you can see, I have mentioned here in red color area 2 00255, this is the red color, area 2, and 02550 is the green color, so area 1. So if the vehicle is going correct side, which is this one, so the vehicle is first come inside our area 2, then it will come inside our area 1. But if the vehicle is going wrong side, so first it will come inside our area 1, which is green color, and then it will come inside area 2, which is red color. Simple. So this is the basic method. This is how we can simply say the vehicle is going wrong side. If the vehicle is first inside our green color polyline, and then the same vehicle is basically inside our red color polyline, we can say the vehicle is going wrong side, and we are going to simply capture that particular frame. So right now, as you can see, the vehicle wrong side vehicle is 0 because no vehicle is going wrong side. So here it is, as you can see, I have mentioned the text with the help of CV zone put text method. So let's just say here I am skipping the frame one by one. So there is no detection because we create here a condition. As you can see, we create here a condition with the help of cv2.point polygon test, because I have explained this code in several previous videos. So you definitely know we have the center point, and simply with the help of cv2.point polygon test method, we can simply say if my object center point, if it is inside my area, so here it is, our area is basically the polyline. So we can simply say if my center point, the object center point, if it is inside my area, then only we want to detect here a object. So here it is, as you can see, we have here a result. This is just a variable. We have here cv2.point polygon test method, and inside that we have mentioned np.array area 1 np.int32. This is what our area 1. As you can see, we need to simply copy paste the area 1. This is what our area 1. So I have mentioned area 1, and then what we are going to detecting? We are going to detecting the object center point. So object center point is basically cx and cy. So as you can see, I have mentioned here cx and cy. So it means this cx and cy, if it is inside our this area, then only we are going to detect our object. For that right now there is no detection, as you can see, because this vehicles is not inside our area. So this is what our first condition. If the vehicle, if it is inside our area, then only we want to detect our object, then only we want to assign the ID, then only we want to track our object. Simple. So this is what our first condition. Now the main condition is what? We want to detect here wrong side vehicle. For that, as I mentioned, we have a vehicle flow. So this side is perfect side, and if the vehicle is going like this way, the wrong side. So simply, as I mentioned, if the vehicle first come in this area, then this area, it means the vehicle is going correct side. So for that vehicle, we don't want to track, we don't want to assign the ID, we don't want to count. We only want to count the wrong side vehicle. So simply, as you can see, this is the correct side. I am skipping the frame. So when this side vehicle, which is going correct side, if it is inside both area, there is no detection. As you can see, for this vehicle we have detection. Basically this is the detecting this vehicle. As you can see, the center point is on this vehicle, but as you can see, this vehicle, it's cross over both area, but there is no rectangle, there is no center point, there is nothing, because we mention our condition. If the vehicle it is in first area, then we are going to save their ID. As you can see, I have mentioned here ID and their current position. So ID is basically a tracker ID, and current position is basically their center point. So we saving their ID and current position in our A1 dictionary. So we have now ID and their current position when our vehicle is in our area. But now we simply say if the vehicle is in our area and the same vehicle is in our second area, this is what our direction for going wrong side. We don't want to count this direction, which is correct direction, we want to count this flow from this side. As you can see, this vehicle is going this side. So simply first this vehicle will part of our green area, then he will part of our red area. So first area 1, so we mention here area 1, then when our vehicle inside our area 1, we are saving their ID and current position, and then we simply say if the ID, if it is inside our area 1 and the same ID, as you can see, if the ID in A1 means the same ID is inside A1 and the same ID is basically now inside our area 2, then only we are going to count our vehicles. So for that, if ID in A1 result 2, then we mention our condition, which is cv2.pointPolygon test np.array area 2, because now the same vehicle is crossing our area 2, so area 2 and same center point. And then if the result, if it is greater than or is equal to 0, then we are going to draw the rectangle, there is circle, there is a counter. As you can see, I have mentioned the counter.count ID is equal to 0, because meanwhile crossing the both area, the ID will basically again and again count. So for that we want to mention if counter.count ID is equal to 0, then counter.append ID, we have here counter list. Inside that list we are saving their ID. So this is basically list of our ID. So list of ID means we have the length of counter, our list. So simply the length of counter is basically our counter. So I have used here cv1.putText method, and then simply we are going to put our counter on the frame. That's it. And then we done with detection. We have counter all these things. We detect our wrong side vehicles, and then we want to save our vehicle inside our folder. So in this frame, because we skip our frames and we detect already the one vehicle which cross our area and the wrong side vehicle is 1, it means we already create the folder and we save that particular frame. So if I open our repository, as you can see, there is a wrong way folder, and inside that we have our image. So if you open the image, and as you can see, we detected our vehicle, there is a center point, there is a ID, and now simply we can say this vehicle is basically going wrong side. So each time if there is a vehicle going wrong side, we are saving with current date and current time. We are saving the current date and current time. Simple. So let's just now, what we are going to do, let me show you here one more thing. This is what our repository in home. So let's just delete our folder. I have deleted folder. Now we are going to start our while loop. 1, save the code and run the code. So friends, as you can see, we have started the while loop. It's little bit slow because I am recording on same Raspberry Pi 4. That's why there is a multiple processes now happening on our Raspberry Pi 4. But as you can see, when our vehicle cross our both area, we have detection, the wrong vehicle 1, simple. So in our repository, it will create a folder wrong way, and inside that we have our image. So if you open the image with rename, so here it is. As you can see, right now the timing is 13:48. So 13:48:26, this is what our timing, and then this is what our date, 2023:10 is the month, and 03 is basically our date, 03:10 month and 2023. So as I mentioned, we are going to basically save our image with the help of current date and time function. This is the image name. So simply, I hope you learned something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.